Hi, I'm Dave. Data sufficiency is a type of question of which approximately 1/3 of all quant questions across all topics are. This is a special GMAT question format. What makes it unique is that it asks us to do something completely different than we are used to. In data sufficiency, we aren't asked to solve questions at all, but only to figure out if they can be solved. Data sufficiency questions always follow the same format. We're given an opening statement in the form of, knowing that something is true, are the following statements enough to tell something else? And then we are given two separate statements, 1 and 2. Here is an example. If x is an integer, is x plus 1 divided by x an integer? So, what do we have here? X is an integer. That's the information we know is true. Is x plus 1 divided by x an integer? That's what we are asked if we can or cannot tell given the following statements. Then we are given two different statements. Statement 1 gives a piece of information. 2 divided by x is an integer. And statement 2 gives a different piece. X is a positive, even integer. We are then given 5 answer choices. Their phrasing is a bit long, but fortunately it's always the same, so we can easily memorize them. A, the first statement alone is sufficient to answer the question. B, the second statement alone is sufficient. C, combined. Both statements must be combined in order for us to have enough information to answer the question. D, divided. Each statement on its own gives us sufficient information to answer the question. Statement 1 is enough on its own, and statement 2 is also enough on its own. And impossible. The data given, even when combined, is insufficient to solve the question. Now, the most common mistake people make in data sufficiency questions is over-solving. Actually solving the question. We never have to do this. Data sufficiency never asks us to solve a question, but rather, it always shows us a question and asks, can it be solved? For this reason, we always want to start by taking a logical approach. Looking at the question and trying to figure out, what types of things can I tell given this kind of information? If we cannot see any logic, we can always go for an alternative approach and try and use numbers instead of variables to solve the question. In this case, our aim is to look for two different cases that result in contradictory answers, which means that the data is insufficient. And if the given data is not in its simplest form, we may use the precise approach of looking for a specific rule or an algebraic simplification that will make it easier to figure out the logic behind the question. So, returning to the example, let's see how we can solve it logically. Let's look at 1. 2 divided by x is an integer. Well, this means x could be 1, 2, or -2. Not enough information to pick between them. Let's cross out A and D. Now let's look at 2 on its own. X is a positive even integer. Well, if x is even, then x plus 1 is definitely odd. So, x plus 1 divided by x is odd divided by even. This cannot be an integer, which answers our question. So, 2 is sufficient to answer on its own. The answer is B. Let's look at another example. If AB equals 64, is A larger than 8? Using the logical approach, we'll start by looking at statement 1. B is smaller than 8 and larger than 0. First of all, knowing B is positive tells us that A must be positive as well, in order for A times B to equal 64. Second, when we get ranges, it's often useful to use an extreme in order to figure out the logic for the entire range. Let's pretend B equals 8. If that's the case, A will also be 8. But B is less than 8, which means, logically, that A has to be larger. And that's our solution. So statement 1 is sufficient, meaning we'll cross out B, C, and E. Now let's look at statement 2. A squared is larger than 64. Now, we must remember to ignore the information in statement 1 and look at this on its own. So, if A squared is larger than 64, A definitely could be larger than 8. 9, 10, 100 all work. But it could just as easily be negative 9. Therefore, statement 2 is insufficient. We'll eliminate D, and there we have it. A is our answer. These were just 2 examples of some of the tactics we can use in data sufficiency. I hope you got the taste of it.